Do you hate brownouts? Worry less. We're here to light it up with VTS, the Visayas Transmission Simulator. Electricity is essential. Blackouts look like a temporary hassle, but they have severe effects in our society. Sadly, our kababayans in Visayas has been experiencing a power crisis for years, which the energy stakeholders have yet to solve. Another gap is the timeliness in updates. NGCP posts in social media more than an hour after the blackout occurs. Much later are news outlets, which report many hours later. It's great not having blackouts, but the next best option is getting access to real time updates to help plan for the day, which most people don't know is actually available to the public. NGCP's live updates are published on the market operator's website. The updates indicate the location, time, and affected plant or transformer or line. It also includes grid updates and yellow and red alerts. And as you may notice by now, the information, though public, is technical and needs an expert's translation. Our project aims to address the gap in addressing the live advisories, particularly for line outages. We aim to improve warning systems by doing a network analysis of the Visayas grid. This would help the public understand what caused the blackout in their area. Our project has scope and limitations that are important to note. The power flow directions assume that supply meets the demand. Only major transmission lines are considered. Line capacities are at a normal threshold. The data were from the market network model. To analyze the Visayas network, we began by web scraping advisories from the IMAP website. We then pre-processed the text in preparation of the EDA, which was done to identify patterns or trends that may be present. Next was a network analysis for centrality measures to identify the important nodes in the network which, when affected, would cause blackouts on a lot of areas. We then developed a Streamlit app to allow users to simulate line outages. The app also identifies the affected DUs and customers, enhancing the understanding of line outage impact on communities.
So we've selected the Visayas grid for our analysis as it is particularly vulnerable to natural disasters such as typhoons and earthquakes, which can lead to transmission issues. Additionally, the grid has limited interconnections, reducing its flexibility in managing fluctuations. The Visayas grid also experiences higher transmission losses due to the extensive distances between lines, resulting in inefficiencies. Furthermore, the region's scattered island geography presents unique challenges for infrastructure expansion, making it a compelling case study for our research. And based on our EDA, we have discovered that a significant portion of advisories in Visayas are related to line outages, with 75% of all advisories falling under this category. Furthermore, our findings show that the majority of line advisories are related to energizing and de-energizing as well as line trippings. We observed that line trippings and restorations in the Visayas region display a random occurrence pattern. This indicates an absence of identifiable, consistent factors or triggers, making it challenging to predict or prevent such events. As a result, it is crucial to further investigate and develop strategies to mitigate the impact of these unpredictable occurrences on the power system. So now, let's move on to Jed as we discuss the network analysis.
Our network analysis project begins by manually constructing the network based on the single line diagram for the Visayas grid extracted April 2023. To visualize the network, we utilize Network X to create different types of graphs, including simple graphs, directed graphs, interactive HTML network graphs, and base map graphs. Next, we calculated centrality metrics such as degree centrality, eigencentrality, and betweenness to determine the importance of nodes and edges based on their connectivity in the network. The centrality scores were normalized for accurate comparison and ranking. Lastly, for the deployment, we want to simulate potential line outages and adding new lines for the future projects of NGCP. Our network consists of 46 substations represented as nodes and 50 lines represented as edges. The nodes are color-coded based on their minor grids. Then, using degree centrality, we identified important nodes in each minor grid cluster. This measure captures the local importance of nodes, so we want to capture at least one important node per minor grid, which are Colon, Ormoc, Cebu, Amlan, Bacolod, and Santa Barbara. For eigencentrality, The top 5% of nodes, approximately 3 nodes, were considered important. Cebu, Colon, and Quezon emerged as the most crucial nodes. In fact, a recent major outage affected the minor grids of Cebu, Leyte Samar, and Panay due to line tripping between these substations. Nodes between Mabinay and Compostela demonstrated significant betweenness centrality, indicating their importance in connecting edges across the network. Just to further enhance our network visualization, we overlaid it on a base map using Contextly with the OpenStreetMap provider. The node coordinates were obtained from Google Maps, and we added labels and lines to accurately depict the network on the map. Displayed here are the key substations discussed earlier, showcasing their important locations within the network. We used all of these network models in a directed graph for the simulation stage of our project, which Kurt will now discuss.
So as reported by Jed, with the high centrality scores of Cebu, Colon, and Quezon nodes, as well as the high betweenness along the Sambuan, Colon, Cebu, Compostela lines, we looked for a significant blackout event in Visayas revolving around the said nodes. This article titled Blackout as Lightning Hits NGCP Transmission Line in Cebu was released August 22, 2021. That is Sunday at midnight. That's over 24 hours after the incident. We quoted some snippets in the article. Number one, the Colon Cebu 138 kilovolt line and Colon Quezon 138 kilovolt line stripped. Number two, blackout in areas covered by Cebu, Leyte, Samar, Bohol portion of the Visayas grid starting at 11:56 p.m. Friday. Number three, the Negros and Panay portions of the grid were spared. So with this, we looked through the advisories on the same day and found out that the line outage was actually reported just 8 minutes after the incident. Now let's see if our simulation using Network X is aligned with the snippets from the article. So from the Streamlit app, we can input the reported lines that went out. As you can see on the right side of the map, the Cebu, Leyte, Samar, Bohol subgrids were affected by the outage, while the Negros and Panay subgrids on the left side were spared. So that is exactly what was reported 24 hours after the incident. Additionally, we got a list of cooperatives, distribution utilities, and high-consuming customers, along with the information on which node they are connected to. The information is also included in the Streamlit app. This will help a consumer check immediately if their provider is affected by the outage. This can also be used by business owners as seen on the table on the right. Now, aside from a past event, we also simulated one future plan from NGCP's Transmission Development Plan for 2040. So currently, Cebu, Leyte, and Bohol are connected radially. If you can see the purple line, so that is prone to isolation as seen in the simulations earlier. Additional transmission backbone to Bohol from Cebu, if you look at the green line, will be constructed since the island does not have a sufficient generation capacity and is only dependent on its Leyte connection. So using Network X again, with Bohol already being supplied by Cebu and converting that radial network to a loop, no significant outages were seen in the simulation given the same event. So in conclusion, the NGCP published text, although very technical, are great sources of electricity grid information and can be made available and understandable by the public through the use of data science techniques. Network analysis using the Visayas grid single line diagram can be used to determine the importances of the electricity grid nodes. Network X is a powerful solution to pinpoint nodes affected by line outages. Lastly, an additional layer of information on the node connections of cooperative distribution utilities and contestable customers makes the project relatable to the regular customer.
In terms of recommendations, we propose the following. Firstly, under project improvement, we suggest incorporating line capacities as well as supply and demand data into the network to accurately simulate a typical grid scenarios. Secondly, we recommend implementing real-time simulations to promptly identify affected nodes and customers. Lastly, we advise extending our analysis to include the Luzon and Mindanao grids for a comprehensive understanding of the entire power system of the Philippines. Moving on to power grid development, we recommend the following. Besides suggesting of adding a transmission backbone from Cebu to Bohol to enhance interconnectivity and improve power supply reliability between the two islands from the simulation that we showed earlier, we propose additional transmission lines to and from Cebu, the load and supply center, to better manage power distributions and meet growing demand. We also recommend strengthening the grid resilience of critical nodes such as Colon, Cebu, Ormoc, Bacolod, and Amlan to minimize the impact of natural disasters and maintain stable power supply. Furthermore, we advise grid reinforcements in Panay Island to support the increasing demand from Boracay Island's thriving tourism industry. And lastly, we recommend constructing new generating units on isolated Visayas islands like Bohol, Iloilo, and Siquijor to ensure adequate power supply during line outage situations and promote self-sufficiency in these provinces. So if you want to further explore the Visayas Power Grid, you can visit our app by scanning the QR code below. Your engagement can help us spark innovative solutions. Again, thank you for your time and for keeping the current flowing with us.